In this video, we're going to be working on the Roborock S7 Max V robot vacuum cleaner that came in for repair. And the vacuum looks something like this. This is the first time I work on such a device. Let's read what the customer wrote. I ripped the traces of the power connector on my robot vacuum located on back of the board, the side with the blue thermal pad. Sending board only, so you may not be able to test the board, but it runs on 14.4 volts. That's fine with me. We do not have to test the board. As long as we fix the power connector, I do not have to test anything. Now I see a lot of connectors here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So he mentioned something about the blue thermal. Oh, here. I see a blue thermal pad right here. So he's talking about this side of the board. The only connector I see on this side of the board is this one here. And this one looks like a power connector. It's a big one. Those, they are connectors for either Flux cables or data cables. So let's check the board under the microscope and see which connector the customer is talking about. Right there. We got it. That's what the customer is talking about. We should be able to help out the customer as long as we know where each pin is connecting to. If the traces are broken, we need to trace the traces, so we know where each pin is connecting to. And right now, based on visual inspection, I believe that this pad, it connects with this via here, or this may not even connect with this. We have to find out. I see some stuff under the connector also. I do not know if there are any traces under the connector. Maybe this pad is connecting from under the connector and not to this pad here. And I believe this one is connecting straight to this component. I'm not sure if this one is connecting here or it's connecting to somewhere under the connector. And this one looks like it's going here. Let's put the meter in continuity mode, or let's do it in diode mode. Let's see if we have a connection on this pin here. I'm not sure if this one is ground or positive. It looks like it's plus. So this, we know it's making a connection, because if the pin was broken off the pad or the pad was broken off the trace, then we would read nothing here. But we are reading 0.4 voltage drop, and that's very good. What about this one? This one I'm reading nothing. So we know the pin is broken off the trace, or the pad is broken off the trace, or everything is broken off everything. I'm reading nothing. What if I press? You see, look at this. Like I said, I do not know if this pad connects here. I can grind this easy, no problem, to expose the copper, so we can connect this pad, this pin, to this trace here, but we do not know if this is supposed to connect with this. What about this pin? Same thing, look at this. This one is obvious. It connects here. And what about this one, which should be ground? Because if this one is positive, one of them is ground, and most likely this one. This trace cannot be ground. And we do not know if this can or cannot be ground. So look at, oh. You see, if I touch the pin here, we're not reading anything. But if I put pressure on it, then we get a reading. So that tells me that this pad is slightly making a connection with the trace, wherever that trace is. If it's in the front here, this guy right here, or if that trace is somewhere under the connector. I do not know. You see, if I put pressure on the pin, pressing down, we get a reading. I'm not getting a reading unless I put pressure. I'm putting a lot of pressure on that pin to read. So what should we do? Should we run a wire from here to here, here to here, here to here, and assume that this connects with this, this connects with this, and this connects with this? Or should we remove the connector and see what's under? Maybe this pin is connecting to somewhere under the connector and not here. Maybe this has nothing to do with this. Which way should we go? The easier way to keep the connector and just run the wires. And the hard, more guaranteed way of fixing this would be to remove this entire connector. And the connector has 2 through-hole pins on the side, which we can remove from right here. There's this coating also on the back. Maybe we can scratch as much as we can. I think I'm going to go the route where we remove the connector, check under it, just to make sure. That's one expensive vacuum, so we have to make sure it works. We cannot test it. We can test the connector. We can test the pins. But of course, we cannot test the vacuum as long as the connector is fixed and the pins are making a good connection. Then our job is done. We do not need to do anything more. Like when a customer mails over a game console, let's say a PS5 or Xbox Series X, and he's specific on what needs to be done, whether it's a power connector or HDMI connector or whatever the case may be, that's what we do. We change the connector. If we have the whole console, we'll test it. If not, then we just mail the board and our job is done. And we do not do stuff that the customer did not ask, because some viewers, they ask, why didn't you clean the top part of the board? It doesn't look clean. What if I clean the top part and the board stopped working? It's not my job to do something the customer did not ask for. Unless something is critical, then we can let the customer know. We see something going on here. We see a burned component here. It's best to replace that component. Do you want to do it? At his own risk. You will only know those stuff when you are in business. You have to be in the mind of the customer. We charge a repair attempt bench fee on any device that comes into our shop. So if this vacuum cleaner came in here, I worked on it and I was not able to fix it, we still charge a bench fee because I spent the time to work on it. For some things like a game console, we have to disassemble the game console, remove the board, work on it, and then reassemble 2 people working on that console. There's a bench fee. And the bench fee is minimal. It's between $50, goes up to $149. It depends on the complexity of the device. So even if that device is a no fix, you will still get charged a bench fee. And we are upfront with the bench fees. We are upfront with the chance of this device being a fix or not. I tell customers, if a customer came in for data recovery, he brought in a hard drive, I'm upfront with the customer. I tell him it's a 50-50 chance, $600 if we're able to recover data, $149 bench fee if we attempted to recover data and was not successful. And then it's up to the customer to decide if he want to do it or not, whether he found it expensive or cheap, or he doesn't like to pay a bench fee. If he says, no, I do not want, here's your hard drive and have a nice day. So if a customer agrees, great. If he doesn't agree, it's up to the customer. But those are the rates. Bench fee is on every device. And the bench fee is only there to compensate for some of the time spent working on that board. Then you have people who tell you, I do not want to pay the bench fee. I do not want to pay the expedited fee. Ship my device back. You're not going to get that device back. So they go online and they bill you with a review, whether it's on Google or Yelp or whatever the case may be. You can leave as many reviews as you want. If you do not pay, you're not going to get that device back. And then they make it seem like we stole their device or we took their device. No, you owe an invoice. You don't pay the invoice, you don't get your device back. It's like this everywhere in the world. You pay to get. You do not go to a retail shop and take something from their shop and not pay them. They're not going to let you take it. Common sense. But we live in a jungle. I always mention it. So let's start by removing that connector so we can inspect under the connector, make sure there are no traces that connect to any one of the pins. That way we can do our job 100%. We do not want to guess. We're going to use low melt solder on those 2 joints, and we're going to use low melt solder on the front pins. And we should be able to safely remove that connector without applying hot air. And we are good here. So I said without applying hot air. We can apply hot air, but at a very low temperature. Look at low melt solder. It stays liquefied for like 5, 6, 10 seconds. Right now we need to apply low melt solder on the front as well. And we need to remove that red glue on back of the connector. Otherwise, even if all the pins are desoldered off the board, we're not going to be able to remove that connector until we get rid of that red thing on the back. You can buy low melt solder from our website, along with genuine Amtech Flux, hot air station, soldering station, grinding pen, power supplies, thermal camera, macro lens for the thermal camera, multimeter probes, whatever we use in the shop here, in our repair videos, on our bench, we carry and sell in our shop. We have everything in stock. And I mentioned in yesterday's video, since we got the warehouse, our stock has increased exponentially. We have everything in stock, and all items almost always ship out same day. Log into NorthridgeFix, click on shop, add whatever you want to cart, order, and most likely your order will ship out same day. Look at this, the pad is completely ripped off. Look, see it? Now look at this pad, it's also ripped off. Look at this. And this one also. Wow. So those pins are not connecting to anything. And this one is connecting to this big pad that connects to this component. So right now we decided to take the long route, remove the connector, so we can do a 100% guaranteed job. Right now I'm using hot air, but I'm not pointing at the connector. I'm pointing on the board. That red glue is like a rock. Let me use the board holder because the board is wobbling all over the place. The board is thick and has a weird shape, so we're not going to be able to use just any board holder. Like if I try to use this one, we're not going to be able to because we have a lot of connectors on the bottom, so the board will be higher than those pins on the board. I'm not going to be able to do it that way. And if we try this one here, it's going to be the same. The board is too thick. What we're going to do is use our NorthridgeFix magnetic board holder. I'll show you. A lot of you already purchased that board holder, and it looks something like this with strong magnets. And we're going to position the board. I mean, look at this. There's a screw curve here that we can use to push on that magnet. And there's another one here. Perfect. And then we can put one right here. And now that board is secure. Awesome. That's what I love about this NorthridgeFix magnetic board holder. You can use it to hold any weird shaped motherboard, like this one. Very nice. And we got it. Done. See, we had some red glue left under the connector, and that's why it took a little back and forth to remove the connector. The board wanna play games? No problem. See, look at this. This pad, it connects to back of the board and not from the front. You see, that's why I removed that connector. Look at this, look at the trace. It connects from the back. One would assume that this pad would connect to the front, to this here. Look at the glare on this board. Let's get rid of the glare by using our anti-glare light. You want to see magic? I'll show you. Anti-glare light on. Look at this. Look at the difference between the ring light. A lot of glare, reflections. You can barely see what's going on the board. And the traces are barely visible. Like this one here, and I do not know what's going on here. Let's put the anti-glare light on. Wow. Wow, look at this. I always use a combination of both the ring light and the anti-glare light to get the image that I want. So we can tell that positive is connecting here, and that's fine. Look at low melt. It's still soft. We need to run a trace from here to here, from here to here, and for ground, right there. We'll scratch, grind this area here, and we will run a wire to restore the ground trace. And that will do it. Look at this pin here. We lost that pin. It's still stuck on the board, but that's okay because we can push that connector back into that pin. Let's focus on the board. Beautiful. See, when I clean, I go from left to right. If I go from right to left, then we're gonna end up pulling that pad off the board. So think outside the box. I mean, even when you clean, you have to do it the right way. Let's grab our V2 grinding pen, and you can also purchase the pen off our site. We have a large stock along with additional tips that you can buy. The grinding pen does come with 7 tips, 7 different types of tips, but the most common ones that I use are the 0.6, which is this one here, the 0.8, and the 2.5. And the 2.5 looks something like this, big one. I use it for bigger jobs. This one here, 0.6, will be perfect. So what we're gonna do is grind from the back here a bit. We need to grind some more on the top. I have the speed of the grinding pen set to low. I can do medium and high. So we have 3 different speeds. But I do not want to grind the living I do not know what of this trace. Just nice and gentle. I think for ground we need to grind some more. So we're gonna grind the big area for ground. Just like that. Now we have to measure to make sure. Hey, what's up, man? Just a minute. We just had a customer that came in to pick up tools, some items, flux, tweezers, solder mask, grinding pen, and a lot of stuff. He had a list of 16, 17 items, and I told the customer, normally we ask you that you order and then come and pick up. That will give us enough time to prepare your order. I told the customer, I do not want to send you home empty-handed. You did not order, but if you can leave for 20-30 minutes, have something to eat, then you can come and pick up your order. So we rushed his order, and he just came to pick up along with his son. His son's name is Javier Jr., and the dad's name is Javier Sr. The son said that one day he wants to become a YouTuber. He's very excited to learn and become a YouTuber. So I told him that I will make your first appearance in today's video. Watch it. That's him right there, a very bright kid, and he looks well raised. I wish you best of luck, and just remember, there's nothing that you cannot do if you put your mind to it. For the ground wire, we're gonna use a bigger wire than the other two. And I'm gonna grab that wire from a Cat 5 cable. Now we're gonna solder it right over here. All right, so we're almost done. We have all the wires soldered in place, and we have a pad for every pin. Now we're gonna apply Flux, genuine Amtech Flux. And we still have viewers ask, what's that gooey stuff that you use before you solder? Flux, genuine Amtech Flux. We are a distributor of the Flux. You can buy in retail or wholesale. Just log in to NorthridgeFix.com and you can purchase from there. Flux is used to help with the flow of solder. Without Flux, you're gonna get bridges, you're gonna get a messy joint. Let's say I wanna apply solder here and here, and we don't have Flux. Let's go ahead and apply solder. Look at this. Look. You see the mess? Look at how spiky that solder joint is. And it just does not sit round on the pad. It does not matter what I do, it does not sit round. Let's apply Flux to this one here and try again. Look at this. Watch. Look at the difference between this and this. This one is round. It will stay round unless we burn Flux off the board, but round joint and you have a spiky joint. It does not do that here because of the Flux. You do not see the mess that we see here. And that's genuine Amtech Flux. That's what a good Flux does. Let's try again with Flux. Look at this. You see? Nice. And what's nice about good, genuine Amtech Flux is it's easy to clean. Let's try to clean it. Done. Just one time. See? Better than factory. So let's go back here and finish with the soldering of this connector. And now we're gonna put that connector back on the board. Just like that. And I'm holding that connector with my fingers because what's more accurate than a finger, right? Just like that. So I'm pressing down on the connector. And let's apply some more flux so we can have some really nice joints. And we're gonna go like that. We can apply more solder here, but let's finish with the rest. And finally, we have this guy here. Apply a lot of solder onto the tip, and we're gonna go like this. And we're gonna apply more solder onto the ground pin. It's a big, thick wire. And just like that. Let's go ahead and test. Make sure all the wires are making a good connection with the connector pins. So this one here is super solid. And this pin is moving along with the wire. We can cut the wire from here, no problem. Let's do that right now. And then we have this one. Let's see if the pin is moving along with the wire. And yes, the pin is moving with the wire. That's very good. And of course, we have a super solid connection here for ground. Let's clean up. We also have to solder from the bottom. We have 2 through-hole pins. Let's do that. Beautiful. Very nice. And now we want to see the wire move along with the pin. You can see it, the wire is right there and the pin is right here. This one and this one. Super solid. Let's turn our ring light on so we can see the pins on the top. Otherwise, we're not going to see the pins on the top because the anti-glare light is shining the light from the left and right in the front, and the ring light will show you the top. That's what I mean by I use the combination of both to get the image that I want. Meter in diode mode. And look at this. We have ground here and I do not even have to push hard. Before we had to push hard for that pin to make a connection with the pad under. Right now we have ground. We have voltage drop of 1.5. You're not going to hear the beep because the voltage drop is 1.5. And you're not going to hear a beep on this one either. Let me go to ohms mode and measure the third pin. And we have ohms reading off 14 kilo ohms. 14 or 15 kilo ohms. And what about this one here? We have ohms reading of 93 kilo ohms, or if we go to diode mode, we have 0.31. Awesome. So all the pins are making a connection. All we have to do is secure the connector from the bottom so it does not wobble and move. Thank you very much, Flux, because I showed you what happened when we did not use Flux. Soldering without Flux is like fish without water. Or maybe that example is too extreme, but you got the point. Let me know what soldering without Flux is like. I know a lot of you have creative minds. Look at that joint. Beautiful. And look at how easy Flux cleans. That's what good Flux is all about. It flows nicely, it lasts when you apply heat, and it cleans easy. And tell me that joint is not better than factory. And finally, what I want to do is apply solder mask. We do not have to, but just to save the world from complaints. We're going to use our 10-watt equivalent lamp, and we're going to put it over the connector like this. And keep it there. It's going to shut off by itself in about 20-30 seconds. We can do it twice because we have a lot of solder mask. And solder mask hardened. Awesome. One last thing I want to do is grab that connector with my tweezer, and we're going to go back and forth. The connector is solid. Solder mask in the front. We have better than factory joints on the back. 1 and 2. And we did an amazing job. We're going to invoice and mail this back to the customer. I hope you enjoyed the video. Let me know what you think. Leave it down in the comments. Don't forget to like and subscribe, and we'll do something else in the next video.